Welcome to episode 44 of Forest Focus, brought to you by the USDA Forest Service Pacific Southwest region. This time, we're going underground in a national forest, into a landscape that sheds light on biodiversity, outer space, and the Ice Age. But part of our exploring requires a rather uncommon mode of travel.
We're just crawling on our hands and knees, all fours, making our way through this low space in the cave. The ceiling continues to drop down. It's going to be a foot and a half high. We got knee pads on, we got gloves on. Can't walk right now, so we're crawling.
There are portals within many national forests that offer entry into realms of the most curious forms of biodiversity. These underground chambers and hallways are called lava tubes or caves. In these landscapes below the ground, tiny creatures creep in the shadows in costumes of faded hues. Their pallor is paired with neighboring life forms that sparkle when hit by a flashlight, as if dusted with glitter. And these subterranean spaces are also archives that contain records of our Paleolithic and climatic past. To explore within, we need to take on the mindset of curiosity. We must train our eyes to see in the dark, to look for what is easily overlooked. We must navigate with gentle movements to preserve features that time has forged over millennia. And as we've just been forewarned, a readiness for crawling will be required. Fortunately, we have an experienced caver to show us the way.
I am Tom Rickman. I'm the district wildlife biologist on the Eagle Lake Ranger District of the Lassen National Forest. We're headquartered in Susanville, California. Today we are on the Hat Creek lava flow, an approximate 24,000-year-old lava flow on the Hat Creek Ranger District. This is one of the lava flows on the forest that has lava tubes, including Subway Cave, a well-known recreational lava tube.
A lava tube begins to form during a volcanic eruption. As hot lava flows through channels of their own creation, the edges and surface are cooled by the surrounding air, which creates a crust, much like ice forms on a river when water is cooled by winter air. Eventually, the crust on the edges and the surface of the lava merge, which insulates the interior lava, allowing it to remain liquid. The molten lava then continues to flow underneath the crust, eventually leaving behind a caved, tube-like space beneath the surface. And when the eruption stops, the lava drains from the tube it created, leaving behind caved space beneath the surface. Once the space cools, it is ready for insects, spiders, and other underground creatures to take up residence. We're here to look for some of those creatures today.
We'll go into a few lava tubes to do a quick inventory. We've had an ongoing cave inventory project here on the Lassen, looking to document the lava tubes, also to look for bats and cave-adapted invertebrates.
Invertebrates are animals without a backbone or bony skeleton. Some have an exoskeleton instead, which is a hard outer covering that supports an organism's body shape and protects its internal organs. Globally, around 90% of all species fall into this category of critter. This includes arthropods, which are invertebrates with jointed legs.
Cave-adapted invertebrates includes a wide range of arthropods, such as spiders, mites, pseudoscorpions, and then also centipedes, millipedes that have become adapted to underground environments that are totally dark and generally with high humidity. And so as invertebrates become adapted to that underground space, they tend to become more elongated. Their legs become elongated. Appendages like pinchers or claws become elongated. They tend to lose pigmentation and become mostly white or very pale in color. The exoskeleton becomes thin. And as far as I know, there hasn't been a systematic inventory of cave biology in caves in the West. There's still a lot of undocumented species to be found to enhance our understanding of biodiversity in general of these lands that we manage.
Documenting a species is not the same thing as discovering it. Indigenous people likely encountered and observed these species previously, but documenting them as part of the scientific record through the process of identification can strengthen the ability of researchers and land managers to understand the biodiversity and conservation needs of caves.
When we do find cave-adapted invertebrates, we have been collecting them. They'll be curated and hopefully in time identified. And so in the course of this inventory, we have found undocumented species. Only one species of which has been published. A lot of others still wait for taxonomists to look at them and describe them. And so a lot of what we found helped improve the knowledge of these systems and the organisms that reside within them.
Before we accompany Tom into his efforts to add to the scientific record, he gives us an overview of his tools of the trade, and nearly all are placed in pockets and pouches of a vest.
So this is like a law enforcement chest rig. Keeps everything tight to your body, and these little pockets will keep a camera, vials, extra batteries, extra flashlight, and it's just tight and readily accessible. And then this is a container just to support photo taking. There's a little measuring gauge for insects. Each of these lines is 6 millimeters, so you have a built-in scale. It's basically just a sandwich container, but because it's used for science, it's a TOS. It's a Tupperware of science, a TOS.
Whether they're being placed in a Tupperware of science for a photographic debut or being placed into a vial to travel for identification, these crawling critters are hard to capture. Most move quite fast, all are rather delicate, and some are smaller than a comma. But Tom has a tool that rises to the challenge.
This is an aspirator where you can suck up insects of interest or spiders.
So apparently we'll be sucking up insects of interest through this straw-like device. Is it too late to abort our mission?
So an aspirator is a long plastic tube with a mouthpiece on one end and then a little collecting tube on the other. You can basically suck up invertebrates of interest into the collecting part. They get caught in this little piece of netting here. Once you have them in the collecting part, you can then blow them into a vial of ethanol, like a self-propelled vacuum of sorts, so you don't really have to touch them or affect them. So it's an easy way of collecting small invertebrates.
Easy, he says. Well, Tom, one person's easy might be another person's terror.
After a small opening that we crawled through, we're now in a space that's about 30 feet wide, maybe 8-10 feet tall. There are crawly sections where the ceiling comes down to 3 or 4 feet above the floor, where you do have to get down on all fours to make it through. But for the most part, we're able to walk through this one. We'll generally go all the way back to the end just to make sure there are no bats that we would disturb by doing the invertebrate search. Then on the way back, we'll start flipping rocks and scanning surfaces for invertebrates. Flip a few rocks, see what's underneath, see if we can see anything new. We often see Terractuses on these boulders. They're pretty good sized, like a daddy longlegs. They seem to be sit-and-wait predators, waiting for a millipede to come by or something to snag. This is a cave isopod. So white, they are similar to those pill bugs you'll find in your garden, the roly-polies, except these don't roll into a ball. If you want to see a very small springtail, it's fascinating. It's majestic. That object floating on this little pool of water, it's actually a living organism. It's maybe a millimeter in length, but if you watch it long enough, it'll actually hop. We had a person here do a springtail survey in the lava tubes across the forest, and in about a week of effort, he documented 9 previously undescribed species of springtail, and 1 or 2 looked this small. If you really weren't focused on springtails, you probably wouldn't see it. A centipede just went behind. So it's a little pale. legs seem to be more elongated than a centipede you would find on the surface. And like where we are is in the dark zone of the cave away from the light. So it could indeed be a cave-adapted species.
And now it is time to put that aspirator to work.
I now got it in the aspirator. Now I need to put it in a vial. Okay, now we have it in the vial, so I can put the top back on. This will make its way to be curated and hopefully, in time, identified to species. Looks like a small spider, but because it was white and way back here towards the rear of the cave, I think it was worth collecting. So now that's in the vial, so now we have 2 specimens.
Considering the size of these species, mere millimeters, begs the question, has Tom gone home with any stowaways on his person?
Yes. In one cave that was real crawly, I got something in my ear, and I could feel it, crawling around. In the evening after dinner, I felt it moving around again. So I used this aspirator. I put the end of it into my ear and then sucked the spider out of my own ear using the aspirator.
Who needs a vial for collection when ear canals are at the ready? For a reprieve from any skin-crawling feelings, we'll turn now to an array of fascinating formations that lava tubes contain from ceiling to the floor, and all of them seem otherworldly. Between root curtains, cave coral, and bizarre bacteria, there is a feeling of being in a reverse realm, or in a waterless ocean, or perhaps outer space. Maybe lava tubes are a bit of all three.
Sometimes in areas where the ceiling is a little bit thinner, roots from trees or shrubs that grow on the surface will find their way into the cave environment. So they'll hang down, take advantage of the high humidity in the air. Some of them are almost like curtains. They're also a good place to look for invertebrates. There's little projections on a lot of the rocks called cave coral, which are a secondary mineralization from mineral-laden moist air that comes in. And as that moisture dries, it leaves the mineralization behind. So these little crustaceans start building up. So that's been like 20,000 years in the making.
This is a good reminder to all of us to tread lightly when we visit any cave. A structure that took shape over millennia can be broken in a millisecond.
So every time we come in, we inevitably break some formation in this cave. I try not to come back in unless there's a specific reason to, because a lot of these structures would disappear just by use. This is the best curve as far as microbial mats. The microbial mats are this little film or growth of bacteria. And some are gold, some are silver, some are more of a tan. They line the walls either in mass or in little fingers, and a lot of it will have little droplets of water on it, condensation, which catches the light of your headlamp. And so when you look at a wall, you have this really sparkly, beautiful color of bright gold or bright silver.
It is, as Tom said, like a shimmering night sky of stars, or perhaps a piece of child's artwork festooned with glitter. But in addition to being wondrous to the eye, microbial mats are also marvels for the mind's investigation on extraterrestrial life.
There are lava tubes on Mars, and so the thought is if there's extant life on Mars, it may be within the lava tubes, and it may be somewhat analogous to these bacterial mats. So there's some researchers who are studying the microbial mats and lava tubes on Earth to help inform the search for life on other planets. So we're way back in the dark of the cave. To the right is a low crawly passage. We can work our way back, see what we can see. unless you want to get a sense of crawly.
I mean, when in Rome.
Okay. Cave ceiling comes down here 3 to 4 feet high, but there'll be another area ahead where it's about 1 foot, 2 feet tall. We're just crawling on our hands and knees, all fours, making our way through this low space in the cave. The ceiling continues to drop down. About 50 feet ahead of us, it'll be about a foot and a half high. So can't walk right now, so we're crawling. We got knee pads on, we got gloves on. It's pretty tough on both knees and hands with this pointed cave coral.
If we're up for some more crawling, and I think we are, we'll need to do so again in another cave, which will allow us to greet a relic of the Little Ice Age.
So we are entering our second lava tube of the morning to take a look at one of the old wood rat nests, the one that was carbon dated to 600 years.
Fast forward a few months from now, and Tom gets more results back indicating that parts of this nest were 2,000 years old. But on we go now in our quest for the nest.
So to get to the actual wood rat nest, we need to get behind those boulders. So back at the rear of this cave behind some boulders is this large wood rat nest, an accumulation of very similar sized rocks. And the vegetation is, decayed to that dark compost soil. A few bones scattered on the surface. The rock pile is maybe 1.5 feet deep and 4 feet wide or so. The surrounding boulders above it are still coated with wood rat urine stains. So this one was probably occupied for quite a while.
At first glance, the uninitiated eye might see a pile of rocks with no story. But to a wildlife biologist like Tom, this pile contains mysteries that proved worthy of exploration. And as he just mentioned, there are a few telltale signs that this is no meaningless rock pile. First, Tom considers the size of the stones. The pile seemed out of place and was made of rocks that were all of a similar small size. He deduced that creatures, in this case wood rats, likely selected and placed them as part of nest building.
These old nests are characterized by a collection of rocks that are maybe 1 to 2 inches long and maybe 1 inch wide. And there's really no other reason for these rocks to be here. They didn't fall from the ceiling. They don't match the surrounding area. And so it seems like they were brought in.
Second, Tom pondered the absence of vegetation. Wood rats primarily use vegetation in building their nests, along with rocks and other objects. But there is no vegetation here. However, Tom noted dark soil at the pile's base in a color and texture that did not match anything in the surrounding area. He theorized correctly that this was soil made from long decayed vegetation that would have once been part of the nest.
Wood rats typically build their nests with vegetation. There's no visible vegetation here. It's all decayed into that dark compost soil. That, to me, indicates that it's old.
Lastly, Tom was curious about the location of the nest. This one is way in the back of the cave, which contrasts sharply with present-day wood rats' nests, which are most often at the front of caves. A possible answer to this puzzlement came through a bit of time travel.
So we've been seeing these for a number of years, and I've been intrigued as to how old they might be or why a wood rat would make the effort of building a nest several hundred feet back in total darkness within a lava tube. And the thought was that possibly these were built during a colder climatic period when nesting in the back of a lava tube away from the influence of the opening, they would take advantage of more consistent, warmer temperatures. And so after several years of wondering about the age of these, myself and a couple other folks took some samples for carbon dating. We got some of the dates back that would indicate that they go back about 600 years, which nicely puts it back into the time of the Little Ice Age. And so indeed, during the Little Ice Age, the surface temperatures would have been much colder. And so they might have been going back deep into the dark of these caves to take advantage of more consistent, warmer temperatures. And now these rocks are almost like trace fossils where they indicate that that wood rat nest was here.
A bit of climatic history written in stones. Back on the surface, Tom leaves us with some reflections on the joy he's found in inventorying these cave tubes over decades of work with the Forest Service.
When we're in these systems, especially in the deeper, darker part of the caves, you build up this bubble of focus where you're going from rock to rock or scanning surfaces looking for spiders or millipedes, centipedes, whatever is there. And you lose track of yourself, you lose track of time. It's just you and your crew with these lights from the headlamps scattered through the lava tube. And it's just the most amazing thing. You just lose track of everything else but just that focus of what you're doing. And then you come out back to the surface. It's like coming out of a matinee movie where you've lost yourself in the movie. And you come out back to the sidewalk and it's a whole different world you have to get accustomed to again. And you just can't wait to go back in the next one. And so to know that what we're doing is improving our knowledge of biodiversity, to know that what we're doing is going to document species that until now have been undocumented, and to know that even now we can make meaningful contributions to our science, I think is all very cool.
Thanks for listening. For those who are curious to learn more, go over to the show description page and click on the links. To find more episodes, search Forest Focus Podcast wherever you get your podcasts. And if you have questions or suggestions for the show, email us at sm.fs.r5ffpodcast@usda.gov. Until next time, enjoy your public lands. Please remember to recreate responsibly, know before you go, and learn what you can do to prevent wildfires. Take care. This podcast is sponsored by the U.S. Department of Agriculture Forest Service, and the USDA is an equal opportunity provider, employer, and lender.